I was a little dismayed the number of people that didn't raise their hand with reliability and how many were in product development. Because to me, they're simultaneous, they're synonymous. If you're designing a product, it is going to be reliable to some extent, less or more to whatever it is. It doesn't really matter if you pay attention to it or not, it will happen. Your product will perform or not perform, however it is designed. Now, a little bit of background about me is I started my career as a manufacturing engineer. And a design engineer would show up every now and then and say, hey, can you run this through the plant for me? Can you build this? This is a prototype or whatever. And some we could make no problem. It's fly through our facility, have not an issue, would work great. They'd learn everything they wanted to learn from it. Other times, we couldn't build it to save our life. We needed to invent new equipment, new processes, everything else, just to get one to work. And so I formed this opinion, and don't hold this against me, but it's always the designer's fault. Always. All right, so reliability has a technical term. Unfortunately, most of our customers don't know this term, this phrase. This is an engineering definition and has 4 parts, right? It's the probability. Everybody loves statistics. I'll just leave it there. It is a probability of something surviving. So you got to know what it is that's supposed to work, right? Define that. What is it supposed to do? And we often write those down in engineering requirements documents and so on. But then it's under stated conditions and stated duration. The trouble is that there's an unstated 5th part to this. And it's a corollary to that your customers don't use this definition. They just want it to work. They paid money for your product or service, and they expect it to solve a problem for them, to add value, to give them a good ROI. Otherwise, they're not going to buy your product, right? Unless you're an artist or something, and then it's a completely different game. The issue is that the 5th part is they will always want less failures. They want their product just to work, and you can let everybody else's fail as long as you stay in business. It's okay, but a customer wants their product to work. They want it to work longer. They want it to work in environments and in conditions that they will never tell you about, and they will use it in places that you have never imagined, right? And probably can't imagine, and they want it to last forever, or as long as they get value from it, right? So the 5th part is these 4 always change. Right? So if you set a reliability goal using these kinds of definitions, keep in mind that 6 months from now, they're already outdated. It'll keep evolving. Your customers expect more as soon as you provide something that works. They want it more features, more functions, longer duration, and so on. The issue is that customers don't use this definition. They'll say, I just want it to work. I want it to work a long time, right? And usually I ask my graduate students, how does your company or how do you talk about reliability? And they'll say MTBF, or it's a 5-year product, or some piece of it, which is only a fraction or a piece of this kind of definition. And then they have endless arguments about whether it's a failure or not, because was that a core feature or not? And they'll argue endlessly about it. Keep it simple. In your company, if your customer sends it back to you, calls you, doesn't buy your product again, goes online and says bad things about it, they all cost you money. Those are all reliability failures, right? They cost you money. And so you start with a clean definition for your engineers, but keep in mind that it's not the whole game. All right. Back to that quick show of hands, right? Between, are you in the design world or do you do reliability stuff? By definition, if you're designing a product, you're doing reliability, right? Whether you pay attention to it or not, your product will perform on some duration of time before it fails. If you are lucky and really good, skilled engineers with lots of experience about your materials and processes, it'll last a long time. Whether or not you do a reliability test or anything else like that. Back to my comment about it's always the designer's fault. Reliability happens not because somebody like me shows up and says, we're going to run a test. It happens because your design teams make decisions every day that affect the outcome of reliability of your product. It's those individual decisions. Do I go vendor A or vendor B? Do I use this rated part or that rated part? Do I use a little extra margin on this component and the strength of this piece, or a little less, right? So many organizations focus on cost or time to market that it makes it difficult to add in that margin, to add in that thought process about reliability. But as you keep in mind that it's the understanding what could go wrong, what are the consequences of that, and it's that decision point that makes a difference. That's where reliability happens. Now, a reliability engineer can help you get better information to enable better decisions. It's really all we do. We influence the decisions, right? You can do that yourself by asking the right questions. What's at risk? How will it fail? What are the mechanisms? What can I do about it? How stable is it? Those kinds of questions. Now, there's tons of reliability engineering tools. Not any of them are specific to a reliability professional. You technically don't need me to do reliability for you. And if that's your attitude, you're already lost, right? You can't just throw it over the wall to me and I'll break it. I did have one person one time, I was in his office, he was making a portable inkjet printer. It was one of the first ideas of the battery-powered inkjet printer. And he said, here's my only prototype, costs us thousands and thousands to make it. It works, but it shows the form, fit, and function, and it has all the mechanisms and features in it. And he picked it up, and he says, how reliable is it? If I give you this one, how reliable is it? And he handed it to me, and I swear he dropped it, but I think he thinks I dropped it. And it shattered. And he said, your reliability is about 3 feet. That's it. It's like, if you give me a sample of one and you want me to answer that question, well, it didn't survive. And it only took 3 feet. And it's a portable device. Come on, drop is going to be a piece of this thing. And so we went on from there. He quietly didn't say anything and motioned for me to leave the room. We ended up working with them, and they made a pretty robust product. The idea is that long before he had a prototype, reliability was already being baked into that product, right? It was already there. And so you can choose to make it conscious or not. And it's a design decision. Mike talked a little bit about consequences in the business part of it, right? Sure, reliability is important. HP at times, and the old test and measurement catalogs now in Agilent are the hallmark of how you can charge more if your product just works, right? HP not so much anymore. I haven't been involved with them, but the old calculators and old laser printers were rock solid. The test and measurement equipment cost twice as much as anybody else's, yet they dominated the market. And it was primarily because their products just worked. Right? It just worked, and they were solid, and they worked for a long time. They set goals to achieve that, to be that much better than the competition. If somebody else came along and made a better signal analyzer, they would study it and make one that worked twice as well with twice the features, right? But it always was focused on making it durable and fault tolerant and all those other aspects of it that makes it just a solid tool that you can count on. Now, how many of you have ever had a supplier not provide, and we'll talk about suppliers later, Rob. So a supplier sends you parts that weren't quite right. Yeah. You know, a big part of our design is relying on that supply chain, right? And so part of reliability is paying attention to that and making sure that you, one, ask them for the right thing, and then monitor where the risks are. And there's a lot more to that. And the last part is customers, is setting expectations. If you say you have a 20-year product, it better well be a 20-year product and survive and work for that long. Because if you get that one failure after 1 year, it's straight to Yelp. It's straight to the review teams. It's, right? You break expectations by not delivering products that do what you say they're going to do. And so data sheets and so on are, to some extent, they're a legal document. And it says it's going to do this performance for 4 years. Well, then you have a warranty to back that up, right? But let me use a story. I got a call And how many of you remember Jawbone? Yeah, they're a Valley company. They made a little product called Up. Remember that? It was like a Fitbit, little plastic, and it was flexible and fit on your wrist. I got a call in January, a number of years ago, and they said, we need you to come in and help us. And I said, why is that? And he said, we shipped for the holiday market a big launch, and 2/3 failed in 2 weeks. We did something wrong. And he said, and we went back into it and dove into it. And they did a lot of right things on the second product, but even with their resources, they didn't recover from it. Right? And there's a number of other mistakes that occurred too. But the idea is that they didn't go down and understand how the customer was going to use it, what expectations they were setting. So one of their ads was a person in the shower or washing their hands or swimming, right? So it should be water resistant. Unfortunately, water got into this device pretty easily. And then after a week, it would corrode the electronics and cause it to short and drain the battery completely. And it was dead. They didn't realize that water took a week to cause that failure. So part of reliability engineering is truly understanding failure mechanisms. If you want to make something water resistant, don't just dip it in the water, shake it off and go, oh, it's still working. It's not sufficient because corrosion takes time. And there's ways to speed that up, but you got to understand the fundamental mechanisms for your product. How will it fail? The chemistry, physics, or software, how will it not work in detail? That's one of the things reliability engineers makes it difficult for us to get on airplanes, is we know too many things about how it will not work. All right, the warranty trap. If you're in a startup, you're under pressure to get a product to market. The time to revenue is crucial to your business success, right? Reliability is this nebulous, it'll happen later, we'll get to it later. We got to get a product out there so we can iterate on functions and pivot and make it work. And we'll sort out failures when they occur. We're optimists. We really want to make sure that we're producing a good product and a good image and a solid offering and all this stuff. And that reliability stuff's kind of difficult and it takes a long time and it's very expensive. We don't have any money. And 75% of your products fail in 2 weeks, right? But even if it's not that, let's say you budgeted for 2% failures and you get 4% failures. Where's that extra 2% of your revenue come from? Or comes out of your revenue, right? But it comes out of your profit, right? I had one customer that they had it was a medical device, and they had a massive profit margin. 50% of their products failed every year in their first year of use. And they had a 2-year warranty. So they were making and shipping 3 products, brand new products for every one they sold. And they still made money, which was unusual. The idea, though, is that once you get into this reactive trap of responding to field failures, of irate customers, of convincing your funders that you still have a good product and you're making progress in solving things and so on, is now you're reactive. You're responding to problems rather than bringing new features to market, bringing better products to market, bringing better solutions to market. In an informal survey over the years, 25% of engineering resources go to fixing the last design. Right, 25%. Now, what could you do with that extra set of engineering resources if it was less than that, if it even cut it in half? In many organizations, that's 2-3 more engineers or more working on new solutions. So it's different than just warranty. It involves your engineering resources, your brand loyalty, your ability to resell, word of mouth, all of those things factor into this thing. The idea of getting ahead of it, though, so that you avoid that trap of being always reactive, is the key to making a reliable product right from the start. Right. The key goes right back to the start, is as you think about your design and your product, it has to include the factors of how is this going to impact the reliability performance going forward. And that's in every decision. Right? From strategy to concept all the way through detailed design, That's where reliability happens. And the engineering work we do is to enable good decisions there. And so, thank you.